Hello again, this is Miss Nakayama, and today's lesson is 6.7, the dot product. It is the last lesson in chapter 6, and I think you'll enjoy it because it's short and sweet. So let's get started. First off, we're going to find the dot product of two vectors. We're going to find the angle between the two vectors, and then we're going to use that dot product to determine if the two vectors are orthogonal. So first off, the dot product of two vectors. Before I talk about that, I want to refresh your memory about what we've already talked about. So previously, we added two vectors, and when we added two vectors, we got a vector. And then we took a scalar times a vector. Remember that scalar is just a fancy word for real number, and a scalar times a vector was a vector. Well, now we're going to talk about the dot product, and the dot product is when it's called the dot product, but you might think of it as multiplying two vectors. And when I multiply two vectors, I don't get another vector, I get a scalar. So if you can remember that these two general concepts, three, what do you multiply? You add, you get two vectors. You multiply a scalar and a vector, you get a vector. But when you multiply two vectors, you get a scalar. It'll help keep you on the right track when you're doing your problems. So if I have two vectors, a sub 1, b sub 1, a sub 2, b sub 2, okay, then the dot product is defined as the sum of their, I didn't get that one right. It's the sum of their products. Come on. There we go. The sum of the products of their horizontal and vertical components. So that's what it looks like. I multiply the A's, multiply the B's, and add them together. That is the sum of the products of their horizontal and vertical components. If you like words, if you like symbols, I'm giving it to you in both ways. So look at these examples. All right. I have V is 7i minus 4j, and W is 2i minus j. Find each of the following dot products. So V dot W means I'm multiplying the A's, 7 times 2. I'm multiplying the W's, negative 4 times negative 1, and then I'm going to add them together, and I get 18. Okay? They want W times V. I'm multiplying the A's, I'm multiplying the B's, and I'm adding them together, and I get 18. There's a product that names that. Look what happens if I do W dot W. So W, that means just W dot itself. So the A's in both cases are 2, and the B's are negative 1. Multiply them together, and then add the products, and I get 5. So right here are properties of the dot product. And if you can write the names of 1, 2, 3, and 5 on your paper when you show me your notes, I'll give you a piece of candy if you're correct. Okay? Now, we have another formula for the dot product, which I really like to think of it more as an application of the dot product. And that is, it looks like this. The dot product is the product of the magnitudes times the cosine of theta. Or the cosine of theta, and this is more of how I remember it, the cosine of theta is equal to the dot product divided by the product of the magnitudes. That's what this symbol is, the magnitudes. And when solving problems, you might go ahead and solve it for theta so that you know which button on your calculator to use. So that's why I've highlighted that one. So any angle between two non-zero vectors is the inverse cosine of the dot product over the product of the magnitudes. Let's go do an example. Find the angle between, this is example 2. Find the angle between two vectors, V equals 4i minus 3j, and W equals I plus 2j, round to the nearest tenth of a degree. So I'm looking for an angle. The angle between two vectors is the inverse cosine of the dot product over the product of the magnitudes. So I'm going to go fill in. My dot product means I multiply the A's. 4 times 1 is 4. Multiply the J's. 2 times negative 3 is negative 6. The product of the magnitudes, you can put it in your calculator in one fell swoop. So that's the square root of a squared plus b squared times the square root of a squared plus b squared. and you put that in your calculator. Again, if you have a good one like that black one, or even the teal one will do it, okay, that has a horizontal fraction bar, then you should be able to put that in one fell swoop and not mess up on any calculations in between. And you will find out that theta is 100.3 degrees. Okay? Last thing to talk about is parallel versus orthogonal vectors. So two vectors are parallel when the angle between them is 0 degrees. And if it's 0, they go in the same direction, like this picture right here. Or if it's 180 degrees, and if it's 180 degrees, they go in opposite directions. So what you might pay attention to is if the cosine is 1 or the cosine is -1, if you don't go ahead and push that button of inverse cosine when you're solving problems. Okay? Now, if the angle is 0 or 180, they're parallel. They are considered orthogonal when the angle between them is 90 degrees. So in case you haven't figured out, orthogonal, y'all, is just a fancy word for perpendicular. That doesn't really look like the perpendicular sign. Try that one more time. How's that? Okay, so the last example that we have is determining whether two vectors are orthogonal. Our vectors v, which is 2i plus 3j, and w, which is 6i minus 4j, orthogonal. So I'm going to go use my cosine. My formula for the angle between two vectors is the dot product. Multiply the a's, 2 times 6. Multiply the j's, 3 times -4. Now, if you know that's 0 on top, it doesn't matter what's on the bottom, but I'm going to go ahead. Square root of 2 squared plus 3 squared, because that's the magnitude of v. And the magnitude of w is the square root of... I did not write that. Look at that, y'all. That should be not a 3, but a 6. Thank you for paying attention. I didn't get that correctly. Anyway, when you put that in your calculator and you do your inverse cosine, you will find out that theta is 90 degrees, and therefore these two vectors are orthogonal. And that is all you have. You just need to remember the formulas as you go through. And the best way to do that is to write them down every time you practice a problem in your assignment. Thank you so much for watching, and y'all have a great day.